tokens to access it, as well as how to make a blockchain ETL that doesn't suck. Now, this is all going to get a little bit conceptual, right? Blockchain data slides don't really go well together, so we're going to have our friend help us out. Meet Chad the DGen. Chad invests in dog coins. Chad sends GM messages in hundreds of Discord servers every month just to try to get NFTs, right? Chad has his crypto spread against dozens, if not hundreds of wallets, conducting hundreds of transactions so that he can farm all the tokens that he can get. For most of us that are building products, right, Chad is our target demographic. He generates volume, he pays transaction fees, and he's very active on social media talking about our products. So, you're right, Chad, you don't struggle with blockchain data. Everyone building products for him does. So, what we do is blockchains offer this really awesome, decentralized, global data store, right? No one needs permission to be able to work with it. And with that, Chad's able to send crypto to anyone in the world for really low transaction fees, 24 hours a day, right? He can interact with smart contracts, he can mint NFTs, do NFT swaps, et cetera, Cool. So what about all of us that build products for Chad, right? How do we retrieve the data that he needs, right? All of his DGen activities. Chad expects a Web 2 quality experience with personalized experiences and fast load times. This should be easy enough, right? All the data on the blockchain is public. How hard could it be? Well, just because something's public doesn't necessarily mean that it's easily accessible, right? What is accessible is access to blockchain nodes. And as what many of you may know, right, access to blockchain nodes means that you're using an API. Typically referred to as an RPC API. Well, this is you just out of blockchain development 101, building your first application, right? You're attempting to make your RPC calls, and you're finding, hey, this is really easy. I can make an RPC call to get a transaction, and I can see it nice and easy, right? It's free in a lot of situations. You can go sign up for a free account on Quicknode, various other providers that you probably shouldn't sign up on, or you could run your own node. And that's great, right? You can immediately get started, you can access the data right away, and the APIs are standardized, right? No vendor lock-in. What other place in the world can you access that? That's awesome. But when you first start using RPC APIs, then you get humbled pretty quickly. You start to find that the data's encoded, right? Decoding interactions with smart contracts requires access to these ABI files that are hard to find, and they're also not on chain, which makes it extremely difficult. Data, when you want to extract it, you have to extract it block by block. You can't just say something like, hey, for Chad, give me all his transactions that he's had. You have to slowly go through and say, okay, in block 1, let me filter down to all the transactions for him. Block 2, block 3, block 4, which is extremely inefficient, right? And also, the transactions that are happening that are associated with Chad aren't easy to just see, hey, let me see his to and from address of a transaction, and that's the ones that are associated with him. No, it's a lot more complex than that based on the smart contracts he's interacting with. So really, to get all of the information that Chad needs, you could be doing billions of API requests across chains. So in summary, right, node APIs are good for requesting a single transaction, right? Or are they? Let's take a look right here at the API response for a simple transaction for a USDT transfer. Yeah, I can't read it either. So to decode this, right, we need access to the ABI. And once you can find it, it's actually pretty easy to show something like what Etherscan is showing right here, right? For those of you who over there can't see, it just says, hey, it's a transfer of 40 Tether from Chad to random address. So Chad's happy, right? He can see his transaction. Well, what if we want to show him a more advanced experience? Something like, hey, what are all my ERC20 token transfers? Well, that would require millions of API calls to the node, something that Chad is not going to wait for or be willing to pay for. So enter enhanced APIs. Some really good examples that you guys are probably familiar with are things like token APIs, NFT APIs, transfer APIs, etc. This is really nice, right? They handle some major use cases very well. They provide the data decoded, easy to display to Chad, no longer worrying about finding ABIs, etc. They're typically really inexpensive, which is very nice. And you can immediately start using them. You're starting to hear me say that because that's not going to be true for some of the ways to access data that I'll mention later. Unfortunately, not all enhanced APIs will meet your most basic needs. There are exceptions to everything. If you want to have an NFT API, right, that might not support something like CryptoPunks, which doesn't meet NFT standards, right? And if Chad owns a CryptoPunk, you better assume he wants to see that in his wallet. The premium providers, of course, they're going to support those things, but they start to become more and more expensive. So where you'll start to run into more challenges is something like, hey, I want to do something unique that's different from every other platform out there, right? I want to present the data in a unique way. I want to be able to pull some unique data off the chain. Well, with enhanced APIs, you're kind of stuck with the standard interface that everyone else is getting, a fixed set of API methods with a fixed set of fields that'll be in the response. And if you want to start enhancing that data, then you have to figure out, all right, well, I'm going to call this enhanced API to be able to get an NFT purchase, and then I'm going to call this other one to be able to get the price of Ether at that time so that I can say, hey, this is how much it was in NFT, in US dollars, and that just starts to get pretty cumbersome at scale. Another example is if you want to start to do some, custom logic, like, hey, show me the total balances across 50 of Chad's addresses. Right? Chad doesn't necessarily care about like, oh, I want to go to one wallet and then the next one and then the next one and then I want to do all this math in my head, right? He just wants to see his total balance, right? His total net worth. To do that, you're going to be stuck making at least 50 API calls, if not also calls to a price API. So NFT APIs, where they're good for really straightforward standard use cases, if you're trying to do math or any form of aggregation with the data, you start to run into issues. Raise your hand if you've heard of Subgraphs. Great, okay. Raise your hand if you've worked with something like The Graph or Zeev. Good, okay, so people are familiar with some of the challenges here, but for those of you who aren't, subgraphs are an extremely powerful tool. It really actually seems like magic when you first start using it. All you have to do is you start to select something like, hey, here are the contracts I'm interested in, make some additional minor configurations, and then come back in a few days, and it'll have indexed all of the transactions, events, etc. Once indexed, you can really query it very powerfully, usually through a query language like GraphQL. Some people find this to be advantageous. Others find it to be a challenge because it's a completely different networking layer at their edge that they have to interact with. But it does allow you to do flexible queries, something like, hey, give me all of the addresses that Chad has ever traded with, right? Which for a wallet could be a really useful thing to provide so that you're not accidentally putting in the wrong address, you just reuse a previous address you've worked with. Also, there's a lot of value in some of the features that the graph provides where there's like pre-made off-the-shelf graphs, subgraphs, right? A really good example is Masari. They make a lot of them available and easy to use. Where people start to run into challenges with subgraphs is kind of the initial indexing time. This is where I was getting into with the fact that enhanced APIs and RPC allow you to immediately start using them. That's usually not the case if you're making your own subgraph. There's a time in which you need to wait for the index to get created. And that's not really that big of a deal in isolation. If you're just launching a new product, it's okay. All right, I'm going to take a few days, I'm going to build up my index, and then I'm going to launch it. But the problem becomes if you run into an error during that indexing. You have to redo that index again, and if you have a bug in your system, Chad's not going to be happy to just have to come back 3 days later for it to be resolved, right? So that's not actually the only delay you'll experience on some graphs. A lot of them have a little bit of a data lag for the data to be processed on chain, then go through the data pipeline. So if you want to give Chad the ability to be up to date on the latest activity on chain, so he's most informed, this might not be the best solution for you. One of the most significant challenges that we found that people run into actually is that subgraphs and the processing are actually a little bit of a black box. So if you want to be able to process something like off-chain data and pull it in, while some platforms do allow you to do this and have this composability, it becomes a really big challenge to be able to debug that. And we found that our customers prefer to be able to pull things into their own data warehouse and process it through their own data pipelines. So overall, Subgraphs, extremely powerful tool, but the feedback that we hear is that they prefer to have their own data warehouse. So this data warehouse, right? By pulling the data into a data warehouse and building your own custom index, you've unlocked Jedi Chad. The possibilities are pretty endless when you have the data in your own data warehouse, right? You can do any kind of visualization or personalization for your users. You have access over SQL, or you can write apps above it to interact with it in any language of your choice. And it has tight integration into your existing data pipelines. Let's say you have a Web 2 platform and you're doing some form of processing, maybe bot detection as well, things along those lines. You can do that powerfully within your own warehouse. Also, you have composability with additional data sets. That is a huge challenge with subgraphs. Something like even cross-chain data gets very difficult with subgraphs. So this is a way that allows people to do that at scale. And you can enrich that data, right? Like I mentioned, something like being able to have bot detection or run analysis to determine wash trades, right? Start to get to that real data that might get away from this banter that we have on Twitter these days about, oh, hey, this is how many DAUs I have. Well, like, are those actually users, or are they just addresses that are being farmed? So, let's say we want to be able to help Chad report on his taxes with cost basis info. That requires off-chain data of dollars, right? Let's say we want to show Chad the Twitter handle for the owner of an NFT he wants to buy. Well, again, we need to marry in off-chain data. Chad's ROI over time, right? Or chart Chad's ROI over time. These are all really important use cases that any user wants to be able to have solved. So building all of this, of course, comes with its own challenges. Again, there's an indexing delay. You have to go and you have to scrape the whole blockchain. Again, that could be millions, hundreds of millions to billions of API calls. And an advantage here, though, as opposed to subgraphs, if subgraphs, you usually have to redo your whole index if you have an issue. With this, you might be able to identify, hey, I only need to re-index a subset of the data. Reorg handling. Who here knows what a reorg is? Okay, real quick. Reorg means that historic data on the blockchain changes. Means, what a surprise, blockchain data actually isn't immutable to start. This actually is a bigger problem than people realize. They only find it when they start to build something like this. For example, Ethereum has over 30 reorgs per day, so it's not something that's an edge case. You have to solve for this. Polygon will have reorgs that go back up to 10, 20, 30 blocks that you might have to go and reindex. That becomes a huge challenge for people building these systems. And obviously, building all of this comes at a cost. You have your engineers that need to try to build out an indexing system, scraping the data from the chain, identifying, okay, well, I want to be able to do this as quickly as possible. I only have a rate limit up to X RPS. How am I going to maximize that? Build in my retries for errors, handle my reorgs. It's a lot. And then, obviously, there's the maintenance and the infrastructure to run that. So maybe the key qualifiers, if a custom index might be right for you, is you want to do any kind of advanced differentiated experiences for your customers. You want to be multi-chain, you want to marry in off-chain data, and you want to be able to have data enrichment pipelines, things like wash trade detection or bot detection. But what if there was an easier way? So today, we launched our Streams product, where instead of you having to pull each transaction, each piece of data off the blockchain via an API, we actually feed it directly to you. We take the raw data and we feed it to whatever data store or messaging service you might be using. You can see some examples right here. For the people on the other side, we have examples like webhooks, S3, Kafka, Postgres, Snowflake, etc. What is it that you're using? We want to make it as easy as possible and available to you. And with that, it really solves some of the core challenges associated with extracting data. The reorg handling, that is a huge problem for people. We provide tools to do that for you. We'll restream the data. If you want to just overwrite within your system, you can do that as well. You can set up a trail delay so that it doesn't end up running into the reorg at all, etc. Early customers of this product have seen a significantly faster backfill versus RPC. Especially when you can hook directly into your existing systems and you don't have to worry about some of the latencies associated with APIs, that's where they're seeing the most impact. So while streams might significantly reduce your data extraction, infra, and engineering overhead, there's still obviously some limitations to it. One is that we only give the raw data. We're not processing the data. And this is actually a purposeful design decision on our part, and that's because we want to get it to you as quickly as possible. We have customers that say, hey, I want to be the one processing it. I have my own pipeline set up. I'm providing differentiated experiences through this, so we want to just get them the standard on-chain data. Also, still, to provide these experiences, you need to build and maintain infrastructure for the in-house transformation. Or do you? Also being announced today is Functions. Functions is akin to AWS Lambda. Raise your hand if you know what AWS Lambda is. Okay, great. So that allows you to just take arbitrary code, run it in the cloud. In the context of streams, this really allows you to do things like filter the data. Let's say you only want to send data downstream for, I don't know, ERC20 token transfers. This can significantly reduce the load on your infrastructure as well. You can also transform the data right at the edge. So decode the blockchain data or structure the data in a way that your destination might want. Let's say instead of sending it into your data warehouse, you want to be feeding the data directly to Twilio to send text messages to your users. You can do that right within our function, configure the request directly how Twilio expects it, and then no longer have to run any infrastructure on your side to make that happen. And obviously, you can also enhance the data with API calls to additional services, right? So let's say you want to make a call to a CoinGecko API to be able to get the price data, or you want to make a call to IPFS to be able to get the NFT, right? You can do that right within these functions. This is all available in your choice of language. Out the box, we support JavaScript, Python, Ruby, Go, PHP, Java, .NET, and even Docker images. So pretty much anything that you want to be running, you'll be able to run at the edge on our infrastructure. And now this means that you've freed up your engineers and infrastructure budget to be able to provide more strategic experiences to your end users. So what are the challenges that we still have left, right? Obviously, you still have to build those functions, right? You have to figure out how to transform and decode that data. As the head of DevRel, that's actually one of the things I'm most excited about is start to provide a library of functions for people to use so that it's one-click deploy and it does it the way that you want, enter in your code, whatever it might be. And I'm really interested to hear from you guys if you're looking to build something using these tools. How do you want to use it? Because something like Lambda is infinitely configurable. Whatever you want to build, right? I'd love to hear it. Also, we don't necessarily know what other challenges people are going to run into yet because we don't have customers using it. It's in private beta. We're ready right now for people to sign up, and start giving it a try. So to summarize this all in one chart, this is my attempt at it. On the left, you'll see something that I call total costs. Some of you might be familiar with the concept called total cost of ownership, TCO. That is your infrastructure cost, your engineering time, as well as the services that you're using. Again, Node APIs, very low cost. Enhanced APIs, very low cost. And then on the bottom, we have your ability to provide any unique experiences associated with blockchain data. As you come to the right, something like Subgraphs, you start to be able to do more advanced features, and when you bring in a custom index, right, that becomes very costly, but we're starting to provide you the tools to make that as simple and inexpensive as possible. So, thank you all for coming to my CHAD talk, and if you want to follow up and look into any further information, here's a QR code for streams as well as functions. Thank you all.